couple of years ago I got a Ep.34 that you can see here, and it's got it worked for a while, and when I tried to display it on, or wanted to display it on a classic computer fair recently, it just didn't start up anymore. So I decided to give it an overhaul, because it also has a missing shift lock key. And yeah, I wanted to make this video a video about repairing the pad, but in the end it came to be a video on pad keyboards. So stay tuned. So let's look at the keyboard first. So if you look here, there is a hole where the shift lock key should be. Someone has already been working on it, and we'll have to see if I can find a replacement, or something else I could do is I could take one of those, which is a keyboard from my MicroPad, PCB designed by Steve Gray. I created the support, and you can actually use that just as well, which actually looks pretty cool if it were black. Anyway, luckily I did get the actual keycap, so I can use that. It doesn't have any inlay, and very good forum user on the Classic Computer Forum in Germany has created 3D printable replacement, so you can actually use this key in place. So let's see how that works out. So here we have the keyboard. Here's the hole, and I 3D printed several versions of those adapters in slightly different sizes, because if you put them here in a different order, so for example the smallest one basically almost falls out, and the largest one does not even fit. So I think 105% should be it. But then I also need to look at where to solder the actual cables for that one. So I have another one which I have to fix, which is from my original pet clone from 30 plus years ago, and you can actually see that it has those cables somewhere here connected, and I'm going to take those apart and compare them and see where I have to solder in the cables for the other one. So what I'm going to do is I am going to clean the keyboard, so I have to take out all the keys anyway, and you have to be very careful not to break any of the inner parts and not to lose any of those screws, because they can easily spring away. Sometimes you may end up just getting the top part of it and the inlay still being there, so you have to be careful to take that out as well. and then you can combine them again. Watch out for there's only one way that should work. So I finished taking the one keyboard apart, and I started taking apart the other one. And what you can see here, this is a completely different mechanic for the keys. So they look completely different, and we'll have a look at them more closely later. So as you can see, this one is this type of mechanic of switch, and this one has completely different one. Even the space key is different. Yeah, I have to look at them differently. And if you look at the back side, you also see that the PCBs are different. Different holes in different places. The length of the connector here is different. So yeah, well, let's see. So I've unscrewed the PCB from the keyboard body, and as you can see, someone has been working on that already. So what you can see here, for example, there is some glue where screw holes have been broken and then have been tried to repair with some hot glue, I guess, or some other glue here. Here even the screw hole is completely done. Here it's again lots of glue here. You can see those switches. Basically, they get out like that, and if you turn them, put them back in again, they have a direction. And the reason is because, of course, the keys have a direction too. So you can only put them in one direction. And I hope I got the right one here. Okay. So I'll try to keep it that way, not taking it apart any further. Let's look at the PCB. So also on this PCB, someone has been working on it, has been putting this bridge seemed to have been broken, that had got fixed. And one thing I noticed, which is very strange, if you look at this key connection, this is where the pads from the switches go on and make a connection. You see this trace going here, over here, and there's a little hole in there. When you take the other side of that, goes here, here, goes to the other side of the hole. And there's a couple of traces that actually cut off, basically a shortcut between the two pads of the same key, which is rather strange, I think. So for the shift lock key, I have to find a way where to solder the two cables that are the same signals as the one from the real shift key here. I'll probably take one of those on the bridge here, and maybe this one on the other side. So I'll have to try out how that works, because it kind of has to be long enough so I can take it apart again, and so on. So we'll have to try out a little bit. So what I've done is I have soldered a little cable here and put it through this one hole, and now I have to mount this stuff together. Actually, this is the inlay that is 3D printed. I put it in there. I can't get it out anymore to show you. So, which is actually means it totally fulfills its purpose. So this one goes here, and then what I need to do is actually without, because if I turn the board, everything falls out. It has the space key already, I guess. So I have to put the cable through here, and the shift lock goes like in, and I have to watch the orientation of the shift lock key, so it goes readable to the space key. And of course I forgot that part. So this goes through here, and it fits in here like this. Then I have to take it like this, put it through, lock it in, and now I have to put those. Can you see it on camera? Yes, I guess. To these other hole. Actually, both of them. So, and then I have to solder those two together back again. I have put back all the keys, and what I didn't show is I cleaned them all, I cleaned the board and so on, I cleaned the contacts inside, but here, that's what I wanted, that's what I really wanted. That's the shift key. Now let's go and test it. So I put it into my Ultipad prototype. It's actually not that bad looking either. So let's test it. So if I go to all like options, I can go, so those cursor keys are working. Left shift key is also working. And shift lock is also working. So that's pretty cool. Put it in there. See if all the keys work. Everything works. So pretty cool. So that's now a fixed keyboard. So with the first keyboard paired, I'm looking at the second one. I've removed all the keys. I cleaned it up a little bit. I also cleaned the keys. And now going to open it up and yeah, see how it looks inside. As you can see, I've taken apart the keyboard. I not only had to unscrew all those screws here, but I also had to unsolder the shift lock key, because that's of course connected to the PCB. And if you look at the PCB, it's by Mitsumi, and it's got two separate distinct pads for each key, and those are bridged by those graphite contacts here. If you push the button, then it goes here on the board and makes contact. And so also the case of the keyboard looks very different from the other one. And this one goes here. Yeah, watch out for the orientation. And yeah, so luckily I have one extra of those, so I can replace the one that's broken. So this is the key that has been broken and has broken off, and you can see part of that stem is still lodged inside, so it's broken off. You can see here, this is how this should look like. Yeah, with this cross-shaped form here to go into the key inlay. This is luckily the one that I have extra, so I have a couple of things here extra. I even keep the broken ones because you never know, or you might need those graphite parts and the other parts of it at some point in time. Now the real problem is how to get this one out. So I could potentially replace the inlay completely with one of those, but I would like to prefer to save it, and I'm going to try to screw in with a self-cutting screw and try to pull out, well, that cross shape in there. Let's see how it goes. So let's try this. At least that is how I did it last time, and without camera. So, but yeah, well. You can probably see it. The screw has already cut its way into that middle part. Let's try a bit more. Let me try a bit more and then see if I can pull it out. Oh, okay. So I pulled out the inlay with it. Not what I had in mind, but yeah. There we go. You can see it. The inlay comes clean, and there is the part that has been broken off. You can see how much I drilled it in. Yeah, that's how I wanted it to be. Excellent. So I have the keyboard here, and I'm putting in the replacement part. That's it. And now I'm ready to assemble. Well, almost ready. What I'm going to do is I'm going to clean the PCB. Even though it looks really shiny, I'm going to switch over it with some IPA. So I've almost finished the whole keyboard, putting it back together. The last thing is the spacebar, and I have a couple of springs left, only they don't fit. Actually, there are smaller ones among them. One I found was under the asterisk, and if you look very closely, you can probably see them. I think it's under the 8. So let me pull out the 8 again, and just as a warning, yeah, that's a smaller one. This one fits here. Make sure you either do the spacebar first or put the springs for the spacebar in a separate place. So also make sure you heard the clicking noise. So this is because you really they have to lock into place, otherwise you can just pull them out like, yeah, I don't have one anymore. Then we can mount keyboard. I'll make sure it looks like this. Then you go and put in the springs, and then move it over. There you go. Finally. Unfortunately, I modeled the connector along the as the connector for the SK keyboard, and the only machine I have right now is upstairs in the attic, where I have to go to test it. So this is my self-built computer from way back in the 90s, and this is the keyboard that is going to be connected here and goes in like so. And so let me connect it. And I can take it out like this, and I can switch on the machine. And you get your beep, classic beep, and you get the keyboard basic prompt. And as you can see, okay. Oh, correct. I did not yet solder back the shift lock key. So that's why the shift lock is without effect. Okay, that's looks good. That's how I like it. So today we have been looking at two different types of keyboard for the Commodore PET. One is from Mitsumi, and the other one is what I think is an original Commodore. They have a totally different inside, but still work well as a Commodore PET keyboard. So, but you have to make sure when you want to repair one, which one of those it is. And yeah, I hope you like it. So the original plan was to make a video on repairing this PET 3032, but that had two problems. One was the missing shift lock key, which I have replaced now, and the other one is it still doesn't start. So but looking at the work I did with the keyboards, I decided, okay, make this one on the keyboards only, and the next video will be about fixing this machine. So, thanks for watching, hope to see you next time.